Hi, I'm Paul Battaglia, and this is Section 1.2. Students arrive at Section 1.2 having extensive discussion of some prerequisite skills, such as evaluating a function or operating with functions. They also have a little bit better of an idea as to what calculus might be about. And so now it's time for them to take away a few more things. Namely, how do I evaluate a limit graphically, numerically? And when do limits fail to exist? So the essential question you want students to be able to answer at the end of Section 1.2 is, what is a limit and how can it be determined? Now, I guess the tough thing here is, how are we going to do that? So strategically, I think a good way to start is by talking about a mathematical practice for AP Calculus. Think of these as more of the practices you take up every day in every class and embed into the lesson to try and get students up to the competence level that you need. Specifically, Mathematical Practice 4C addresses building notational fluency, and students will certainly have that option and the opportunity as they learn about limit notation and how we use that in a problem. So we'd start with an example, maybe with a rational function, and we're looking for a function that specifically has a hole in it. Now, when students graph this function, they may not even see or recognize that there's a hole, and that's what we want. What we want is we want students to be able to look at a table, fill in a table of values close to one specific value, namely wherever that hole is. If you're using an example that we start off in the text with, then you would be centered around x equals 1. Now in this case, we want students to be able to plug in numbers close to 1, and that means 0.5, and maybe even closer, 0.9, 0.99, 1.001. Really get them to see if they can understand the behavior around x equals 1. Now what this is going to do is it's also going to bring up an interesting question. When students try to directly evaluate 1, they're going to get 0 over 0. And this is a chance for us to talk about indeterminate form. Indeterminate form, contrary to what students might believe, that's 0 over 0, not 0. Not undefined. It just means it's indeterminate. We don't know enough about it. So we want students to try and kind of get that idea that we still have more investigating to do. Once students have done this, you'll be able to have a discussion centered around what's happening with the function, not just at 1, but close to 1. Moving through the text, you'll see in example 3 that there are some opportunities for you to look at when a limit doesn't exist. Example 3 does a great job, graphically and numerically, of showing students what the conditions are for when a limit doesn't exist. So some of the things that students might do that you might have to watch out for from a mistake standpoint is they might start to think that when you plug a number into a function, well, that must automatically be its limit. And one way to do that, and maybe get away from that assumption, is to have students look at what's going on at x equals 1, and then maybe move off of that. What's going on at x equals 5? You can use that prior example that we talked about before. Another common mistake is the idea of closeness. Students think that because of their knowledge of a number line, if we're looking at x equals 5, for instance, 4 is close to 5. Well, back when we were in first and second grade, 4 was close to 5, but now it's really not. 4.999, that's close to 5. So the question I get asked a lot is, well, how early would you expose students to AP problems? And the answer is very simple. It's now. Now that we're talking about core material in the AP curriculum, it's important for students to see questions they might encounter in a couple months. It's not too early to start showing them multiple choice questions with limits. And one of the things you might watch out for there is students who struggle or might have a tough time finding a particular answer might now think that because they couldn't get the answer does not exist. And that's not necessarily true. So something to watch for there. I hope all these tips have been helpful for you. I'm sure you'll find much success in Section 1.2.